How's it going, ladies and gentlemen? Mr. Donnie here once again, this time looking at 16.9 acid-base properties of salt solutions. So our objectives are to be able to predict the salt's effect on pH based on the cation and anions present. So believe it or not, salts can affect the pH, and we're going to talk about that. So a little reminder of what weak bases and weak acids do. Here I got an example of a weak acid. Remember that they partially ionize. So that if this is my acid, when it loses that proton, this is going to be the conjugate base. Right? So I'm going to get the fluoride ion. If this is a weak acid, then its conjugate base is stronger. So if I have a salt that has the fluoride ion in it, it's going to mess with the pH, and we'll see why. So salts with conjugate acids. So let's say I had sodium fluoride right here. When it goes into water, it's going to break apart, and I'm going to get the fluoride ion, which is going to be a stronger base. And what that is going to do is it's going to interact with the water, and it's going to steal one of these hydrogens. It's going to go, hey, I'm a strong base. I'll take a proton. And now that has just made an OH minus, which is going to mess with the pH. So something that what we're just talking about is hydrolysis. So hydro means water, right? So hydro has H2O, and lysis means to break apart. Like if you were talking about lysosomes in biology, they break down the food. Lysis means to break. So hydrolysis, breaking down water. All right, so some salts will react with water, breaking it down into OH minus by taking a proton from it, which is what we just saw in the previous example with the fluoride ion in sodium fluoride. So salts with conjugate bases, or conjugates of weak bases. So right here, I know that this looks like I'm getting NH4Cl, and that NH4 is the ammonium ion, which is the conjugate of NH3, which is a relatively weak base. So NH4 is going to be acidic. So what happens is when we put a salt that has the conjugate of a weak base into solution, it's going to break apart. So now that we have this conjugate acid, it's going to give off an H+, which is going to, affect the pH, because pH is negative log of H+, right? So salts with the conjugates of weak bases will also mess with the pH. So when will it happen? When will a salt mess with the pH? Think of salts as conjugates. Think about the anions that are going to be given off. Are they conjugates of weak or strong acids? Conjugates of weak acids will be strong bases and raise the pH, right? Bases raise the pH. So HF is a weak acid, fluoride ion will be a strong base, and if it's in a salt, it will raise the pH. Conjugates of strong acids are weak bases. For example, HCl is a strong acid, so Cl- is going to be a very weak base. It doesn't like hanging out with protons. That's why it's a strong acid. They'll break apart, and chloride ion won't really mess with the pH. It's a very weak base. So do the cations have any protons to give off to act acidic? If it's got NH4Cl, it's going to break up into NH4+. NH4+ has some protons it can give off, and it's going to act like an acid. When both are present, like, hey, I got two ions that act like an acid and will act like a base, you got to look at the ionization constant, and whichever one's greatest will have its influence dominated on the pH. So let's just take a look at some problems. All right, metal ions, well, we got exceptions to those. We'll talk more about those later. How will the following affect the pH? All right, so if I had NaCl, let's think about it. That is an Na plus ion, which is like the conjugate of a strong base, right? So it looks like that could have been NaOH, which is going to be a strong base. And the chloride ion looks like it's the conjugate of a strong acid. Right? It looks like it's the conjugate of HCl. So if I got the conjugate of a strong base and the conjugate of a strong acid, they're going to neutralize themselves and they're not going to have any effect. So no effect there. You think of it this way. If Na plus is a strong base, it doesn't want to hang out with any part of water. Same thing with HCl. HCl is a strong acid. Chloride ion doesn't want to hang out with any protons. That's why it's a strong acid. It's not going to mess with the pH at all. All right, so let's take a look at this one, NH4Br. What is it going to break down into? It's going to break down into NH4 plus and Br minus. So I know NH4 is the conjugate of a weak base, which means that it's going to be pretty acidic, so it wants to decrease the pH. And I know that the bromide ion is the conjugate of a strong acid, right? HBr is one of our strong acids, so the bromide ion doesn't want to do anything with H+. It's not going to hold on to any H+ and mess with the pH. So that tells me that this NH4 plus is going to be what affects the pH. The pH is going to go down, right, because of this NH4. All right, one more. We got K2CO3. So I know K is going to break up, and I'm going to get CO3 minus 2. So these K pluses are conjugates of KOH, which is a strong base, right? And this CO3 minus 2 is a conjugate of a weak acid, right? It's a conjugate of H2CO3. So this CO3 minus 2, well, if it's a conjugate of a weak acid, that means that it is a strong base. CO3 minus 2 really wants protons, and it's going to steal them from the water. So that's going to make the pH increase. It's going to make it more basic. So K, not having an influence, but this CO3 minus 2 is going to have an influence. So big ideas. Anions that are conjugates of strong acids will not affect the pH. Anions that are conjugates of weak acids will raise the pH because their conjugate bases are going to be strong or stronger. pH is going to go up. Cations that are conjugates of weak bases will lower the pH. So if I had a weak base, its conjugate is going to be a stronger acid. If that is something in my salt, it's going to make it more acidic and lower the pH. Metal ions with exceptions will decrease the pH, and we'll talk more about that in the future, so not really too much concern right now. And when conjugates of weak acids and weak bases are both present, you got to look at which one has the greatest constant because it will dominate its influence. If you have a stronger acid than you do a base, it's going to make it more acidic. So to summarize, look at the ions that the salts will break down to. What are they conjugates of? What does that tell you about how they will behave in water? Are they going to take a proton? Are they going to give off a proton? Are they not going to do either of that? And that's it. All right. So interesting topic. I hope you found this helpful. I'll see you in class. Bring some questions. Okay, bye.